If our entire universe is trapped inside a massive black hole right now, you'd never know it. But the evidence is starting to pile up, and it changes everything we thought we knew about reality. The universe, dark, mysterious, and unimaginably vast. But what if there's something even bigger? What if we're all living inside the most colossal black hole imaginable? Here's the mind-bending truth about our universe. It's so massive that we can't see it all from Earth. Scientists observe what they can and make educated guesses. Most of the time, there's just no way to know for sure. Today we're diving deep into how the universe formed, how it might die, and the shocking possibility that it all happened inside a black hole. Everything you think you know about reality, it might be completely wrong. Let's start with what we do know about black holes. These light-devouring monsters come in every size imaginable. We just haven't found one big enough to swallow the entire universe. Yet. Black holes have existed since the very beginning. We're talking primordial black holes from the universe's first few seconds. Picture this, pockets of super-dense plasma collapsing into tiny black holes. Well, not all of them were tiny. Some packed tens of thousands of times more mass than our sun. Maybe one of these cosmic beasts swallowed our young universe whole. And together, they kept growing. But first, let's rewind to the hottest moment in history, the Big Bang. You know the story. 13.7 billion years ago, every atom, every molecule, every speck of matter was crushed into an infinitely tiny, impossibly hot singularity. Then, bang. Everything explodes outward at light speed. In a fraction of a second, all the ingredients for complex galaxies get scattered across infinite space. Here's the problem. Inside a black hole, gravity pulls everything inward. Light, time, your wallet, everything gets compressed, not expanded. So if we're really inside a black hole, the Big Bang Theory has a serious problem. But wait, where does this wild idea even come from? Buckle up, because it's science time. A mind-blowing research paper recently made scientists question everything we thought we knew. Using the James Webb Space Telescope, researchers discovered something absolutely bizarre. About 2/3 of spiral galaxies in one region of sky rotate clockwise. The other third? Counterclockwise. Why is this earth-shattering? The Big Bang Theory relies on the Cosmological Principle, the idea that the universe looks identical in every direction. Galaxies should be spread evenly with random spins. No patterns, no preferences. Turns out they're not random at all. If galaxies across large chunks of sky prefer spinning one direction over another, it demolishes the foundation of modern cosmology. And you know what else loves to rotate? Black holes. Here's something that'll absolutely mess with your head. Take all the mass and energy in our observable universe, plug it into the formula for a black hole's event horizon. The result? Something eerily close to the actual size of our observable universe. Coincidence? Maybe. Or maybe the reason we can't see beyond the edge isn't just light travel limits. Maybe that edge is the event horizon of a black hole we're trapped inside. Think about that next time you stare at the stars. But how would living inside a cosmic black hole actually affect you? Here's the plot twist. Your daily life wouldn't change at all. You'd still wake up, drink coffee, and wonder why your Wi-Fi is slow. The only difference? You'd be living inside the most massive object imaginable. So how did our universe end up inside a black hole anyway? If this theory is true, we'd have to completely rethink the universe's origin story. The Big Bang could still explain how our universe expanded and formed galaxies, but instead of being the absolute beginning, it might have been the moment a black hole in some larger parent universe created a sealed-off pocket of space-time. Our space-time. Instead of the Big Bang, we might be living in the Big Bounce. This theory suggests our universe didn't start as a hot, dense singularity. Instead, it began when a previous universe collapsed. Our universe could have expanded and contracted countless times throughout history, making it far older than we suspect. What kind of black hole could contain an entire universe? Stellar mass black holes? Not even close. These form when massive stars collapse, but they're incredibly compact. If Earth suddenly became a stellar black hole, it would shrink to about 1 centimetre, roughly the size of your belly button. Intermediate mass black holes pack 100 to 1 million solar masses. Still not big enough. Supermassive black holes? Now we're talking. These monsters contain at least 1 million solar masses, and we don't even know how they formed. But even a supermassive black hole that's 10 billion times our Sun's mass would only span about 200 astronomical units, roughly our solar system's diameter. The black hole that could fit our universe would have to be stupendously large. That's not a joke, that's the actual scientific term. Stupendously large black holes, or slabs. These hypothetical giants are so rare they might only exist in unusual environments, like outside our universe. But here's the terrifying part. If we're inside a black hole, it might be preparing to end everything. Did you think living inside a black hole would just be a cool party fact? Think again. Black holes are dangerous and hungry. Get too close to one and you'll get spaghettified, stretched into cosmic spaghetti before dying horribly. We might be inside a black hole that's planning the universe's ultimate destruction. There are several theories about how everything might end. The Big Crunch sounds like a delicious sandwich, but it means universal annihilation. The idea, our expanding universe eventually stops growing. When it does, gravitational forces become so strong that everything contracts. Planets collide. Asteroids rain down like cosmic hail. Black holes devour entire galaxies. Pure chaos until we collapse back into an insanely hot, dense singularity, or until everything forms one monstrous black hole. A black hole inside a black hole. Inception-level madness. The good news? This contraction would take as long as the expansion, billions of years. Even if it started today, we'd have plenty of time. The bad news? The black hole's gravitational forces might accelerate the process. The Big Crunch fits perfectly with the Big Bounce theory. The universe doesn't just compress into a singularity, it expands again in a totally new Big Bang. But this makes zero sense inside a black hole because black holes compress everything. They don't expand. Imagine throwing a ball into a pit of quicksand. That ball isn't bouncing back. Maybe the universe is destined to expand forever? Not happening, because there's another doomsday scenario. The Big Freeze. In this model, the universe reaches maximum entropy, a state where it's expanded so much and distributed energy so evenly that nothing interesting happens anymore. The universe becomes dark, cold, and lifeless. No planets can support life. No galaxies shine. The only survivors, black holes. But even those eventually decay through Hawking radiation. If we're inside a black hole, eternal expansion is tough to explain. Black holes prefer keeping things densely packed, not scattered across infinite space. Then there's the most violent ending. The Big Rip. Seriously, science needs better naming conventions. The Big Rip happens when mysterious dark energy makes the universe expand faster and faster. We don't know what dark energy is, but we know it exists because galaxies are moving apart faster than gravity alone would allow. Eventually, space itself would expand faster than light speed. At that point, physics breaks down completely. If humanity somehow survived until then, you'd be vaporized in less than a second. You wouldn't even register the pain before ceasing to exist. If dark energy can overcome a black hole's forces, the Big Rip could still happen inside one. So yeah, the most violent option remains on the table. There's one final doomsday possibility, the Big Slurp. I'm not kidding, that's what scientists call vacuum decay. Our universe isn't a true vacuum, it's almost empty but still contains particles and magnetic fields everywhere. A high-energy event could cause a region to transition from false vacuum to true vacuum. Catastrophic doesn't begin to describe it. A small vacuum bubble would expand in all directions at light speed, tearing apart the entire universe. But vacuums inside black holes are unlikely since black holes constantly consume matter. Here's where things get truly mind-bending. If we're inside a black hole, that black hole exists in another universe. That universe contains other black holes with their own universes. Those universes have more black holes with more universes. It's an infinite cosmic nesting doll. Every time you think you've reached the end, there's another layer. In this multiverse system, Each universe could have completely different physics. Maybe gravity repels instead of attracts, flinging everyone into space. Maybe pushing something away makes it move toward you. These scenarios sound absurd, but there's no way to know how different universes might be warped. Somewhere billions of universes away, or maybe right next door, there's an identical version of you doing exactly what you're doing right now. There's also a version living your dream life, married to your crush, working your dream job. There are millions of versions of you doing better. But don't feel bad. With infinite universes, millions are also doing worse. Let's get back to that intriguing research paper that started this whole conversation. The thing is, it hasn't been confirmed by large surveys yet. We still have so much to learn about our universe. Maybe someday we'll actually find the black hole that swallowed us. That day probably isn't today, but there are plenty of black holes out there. Someday you might find yourself near one. Just don't jump in, even for a nanosecond. Trust me on this one. Pretty wild when you think about it, right?